Hello, Matthews Gatos here. Welcome back to part 2 of trig derivatives. In this video, we're going to look at the second type of question, which is related rate questions. So here's my recommended step for these types of questions. I want you to identify given and unknown rates. Remember, you're only allowed one unknown. So there might be some cases where you have to do some rearranging of questions to come up with an equation that only has one thing you don't know. So I want you to, once you've done that, make and fully simplify an equation using only variables that match variables in the rates. So for example, if I give you the rate of change of radius with respect to time, you need to know what the radius is. Once you have that equation in place, I want you to take the derivative with respect to time. If time isn't given, use implicit differentiation. So I have two questions to illustrate this concept. Let's get going with the first one. So in here we have two sides of triangles, lengths 15 and 20. So these are fixed. They are not changing. What is changing is the angle between them. So the angle between them is changing at a rate of pi over 90. So as the angle changes, the side changes as well. We want to find out what the rate of change of the other side is with respect to time. We're going to do that at one particular moment in time when the angle is pi over 3. But we don't know what x is. So there's two things that I don't know. Now this is the one that I'm solving for. So I need to figure out what x is. So as that angle's changing at one particular moment in time, drawing a triangle not to scale, at one particular moment in time, that angle is pi over 3. So I want to find out what the x is that goes with that. So I have side angle side there. I can use cosine law. So using cosine law, I'm going to say that x squared is equal to the other two sides squared and added together, subtract twice their product, and multiplied by the cosine of pi over 3. So cosine because it is cosine law. So x squared is equal to 15 squared plus 20 squared is 625. And then we're going to subtract 2 times 15 times 20, which is 600. And then the cosine of pi over 3. Well, cosine of pi over 3 is a half. So we have x squared equals 625, take away 300. So x squared is equal to 325. So let's take the square root of that. So the square root of 325, we'll simplify that into root 25 times root 13. So that's just 5 root 13. So now I know my specific x value that goes with it. Okay, so back up here, we're going to find this general triangle as it's changing. Okay, so again, I'm going to use cosine law. So I'll write this out as x squared equals 15 squared plus 20 squared minus twice their product multiplied by cosine of theta, and cosine of theta will be in general. Okay, so let's just tidy this up a little bit more. This is 625 minus 600 cosine theta. Okay, so now that we have our equation, we're going to take the derivative with respect to time of both sides. So the derivative with respect to time. Okay, so in doing that, I'm going to have 2x dx by dt equals, the derivative of 625 is 0, take away 600 times the derivative of cosine. Remember, it's a c function, so it's a negative derivative, times by the derivative of the angle with respect to time. Okay, so now I'm at a point where I'm just going to plug in the things that I know. So we figured out x. X was 5 root 13, and that's equal to, so here two negatives make a positive, so it'll be 600 times sine of our specific angle was pi over 3, and then our rate of change for the angle was pi over 90. And I just noticed over here I didn't include my dx by dt. I got to continue that down. So let me just make room for that. Okay, so I have 2 times 5 root 13 times dx by dt, which is really what we're trying to solve for. Okay, so let's simplify this a little bit here. So I have 10 root 13 dx by dt equals 600 times pi over 3, which is root 3 over 2, multiplied by pi over 90. Okay, so I'm going to tidy up that right-hand side just a little bit here. So I have 10 root 13 dx by dt equals, and now I want to simplify this a little bit. Okay, so I'm going to simplify by doing 600 divided by 2 is 300. So I'll have 300 root 3 pi all over 90. Now, of course, I can simplify that as well. So 390, they both have a common factor of 30. So I'll divide this one by 30, and then I'll divide this one by 30. Okay. I also notice, lots of simplifying here, that I have a 10 on both sides of the equation. So divide both sides by 10. So what I have right now is root 13 dx by dt equals root 3 pi all over 3. So I'm going to divide both sides by root 13. Root 3 pi over root 13, 3 times 3. And then I'm just going to rationalize my denominator by timesing top and bottom by root 13. So all together here, I'm going to have root 39 pi all over root 13 times root 13 is 13, and 13 times 3 is 39. So that's the rate of change of my side. The side was meters, and the rate of change was in seconds. So my final answer, root 39 pi over 39 meters per second. Okay, in this last example here, we have a beacon located at a perpendicular distance of 300 from point R. So here's my beacon right here. That's a fixed distance. So it revolves, so it's like a light, and it revolves at a rate of 1 revolution per minute. So that's the rate of change of my angle. So 1 revolution is 2 pi. So the rate of change is 2 pi per minute. How fast does the beam sweep along the shoreline at point S? So we're looking at this distance here for X. How fast does that change? And we want to know how fast does it sweep along the shoreline at point S, which is 400 meters from point R. So in other words, how much does it change when X, the distance, is 400? Okay. So looking at this, we have to figure out some things on the triangle. So let's look at the triangle at this particular moment in time. So here's my triangle, not drawn to scale. I have when the distance along the shoreline is 400 meters. This is a fixed distance of 300. And I'm going to look at when it's at theta. So first of all, this is a Pythagorean triplet. 3, 4, 5. So Pythagorean triplet of 3, 4, 5, we just multiply it by 100. So it's 300, 400, and this would be 500. So I know that my height is 500. Now that I know that my height is 500, I can come up with any kind of a ratio that I need. I don't know what that ratio is quite yet. So let's look at coming up with an equation in general. So right now I have x, which I need in my equation, theta, which I need, and 300, which is fixed. So looking at that, that's a tan ratio. So I'm going to write tan of theta is equal to opposite x over adjacent 300. Let's multiply both sides by 300. So 300 tan is equal to x. So let's take the derivative of both sides with respect to time. So the derivative here, 300, times the derivative of tan is secant squared theta times by d theta by dt. That will equal to dx by dt. So now I know back in this triangle, the ratio that I need is what secant is. So secant is the reciprocal of cosine. So cosine is adjacent over hypotenuse. So secant will be hypotenuse over adjacent. So it will be 500 over 300, or in lowest terms, 5/3. So I have 300 times 5/3 all squared, times by d theta by dt, which we said was 2 pi, and that will give us dx by dt. Okay, so we just have to clean it up on the side here. So I have 300 times 25 times 2 pi all over 9. So simplifying this, 309 have a common factor of 3, so I'll divide each one by 3. So then my final answer will be 25 times 2, which is 50, times by 100, which is 5,000 pi over 3, and my units are meters per minute. That would be the rate of change. Okay, so I hope those two examples helped. I have a great Simpson-inspired joke from The Simpsons, a calculus joke for you. What is the rate of change of y equals r cubed over 3? Well, if you take the derivative, it's going to be r dr r, or as the teacher's saying, hardy har har. Hope you liked this video and that it helped. I have textbook questions outlined for you there, and I will see you for the next one.